Hi, I'm John Boland,
And I'm Dylan Ostergard.
and this is our project, A Nuclear Idea, where we will be finding where to build nuclear fission power plants before nuclear fusion becomes available. So very quickly, I want to discuss the future of energy, nuclear fusion. It is the same process that the sun undergoes and involves combining two atoms. It is clean, cheap, renewable, and practically limitless. It's very efficient. And although it's not developed yet, scientists do believe sometime in the latter of the next 50 years we will be able to have actual fusion power plants. The current process of obtaining nuclear energy right now is nuclear fission. It's where you split atoms. It's very similar to fusion, however, doesn't make as much energy and it does produce nuclear waste. However, that's not too big of a problem since we do know how to store it away. Um, by investing in fission plants now, we accelerate the process of abandoning fossil fuels and transitioning towards cleaner energy, aka nuclear fusion. And why we're investing in fission power plants rather than like wind or solar or other clean sources of energy is that the workers that work at a fission power plant will possess knowledge, much of which could be transferred towards working at a fusion reactor. So as I said before, we want to get rid of some harmful energy, fossil fuels, coal. So I mapped out coal mines and nuclear power plants. So if you look here in this West Virginia, Kentucky area, there is a lot of coal mines, but a lack of nuclear reactors. So that's where I'm going to be placing my nuclear reactor. Place mine in southern West Virginia on R.D. Bailey Lake. In this map here, I added a 15-mile buffer zone because according to the NRC, that is the average distance that one travels to get to work. And I enriched the buffer zone, to show the amount of construction workers and coal workers that live within this buffer zone. There are 500 construction workers. You need around 7,000 workers around the peak of construction to work at to build a nuclear power plant, which is fine. We could contract more in, and then you need somewhere from 500 to 1,000 workers to operate the power plant once it's built. And there are 1,000 coal workers, so there are enough coal workers. However, it doesn't mean we can necessarily use all these coal workers, right? Because the only way that could happen is the nuclear power plant has to at least match the energy or surpass the energy made by all the coal mines within the zone. So the next map I enriched layer this time to show the amount of coal mined in 2021 from all the mines within this zone, and it equates to 9 million short tons, which also is around 16 million megawatt hours worth of energy. In comparison, a 1,000 megawatt capacity nuclear reactor running at 90% capacity over a year will produce just under 8 million megawatt hours. So what that means is we're making this the nuclear power plant will make less than half of the amount of energy made by all the coal mines in here, which is something to consider. So we will not be able to use all these coal workers. Also, I did not point this out beforehand, but it takes 5 to 10 years to build a nuclear power plant, and during that time, we will educate the workers so they can work at a power plant.
So the location I chose is just outside of Corpus Christi, Texas. And as you can see, we're trying to eliminate some of the oil drills, as there are historically have been over 10,000 in the Gulf of Mexico. And moving on my map, you can see that we also enriched a 15-mile buffer zone to show the average commute to work. And I put it here so that way we could pull workers from Corpus Christi. And Corpus Christi has over 15,000 construction workers and over 1,500 extraction workers. So we have plenty of workers to build it. We may still need to bring in more extraction workers to work in our power plants, but eventually we will have enough people by the time that it is finally built. So, conclusion, nuclear fission is a highly versatile and efficient energy source, surpassing traditional fuels like coal and oil. The chosen sites are perfect for nuclear reactors as they can help replace harmful energy sources with clean energy. However, in West Virginia, there is a shortage of local workers to manage the power plant post construction. Recruiting structurally employed individuals can solve this issue. Modern nuclear fission plants can last up to 80 years, and building these now prepares us for the future of nuclear fusion, reducing reliance on oil and coal. Nuclear energy is reliable, efficient, and crucial for advancing humanity's energy future.